I have shared my screen. I'm going to start talking about the Slurm job scheduler and Matlab in the terminal. So, if you haven't worked with batch jobs before or at HPC centers, then you may wonder, what is a batch job? And how do I make a batch job from Matlab? And also, how do I configure the cluster from Matlab? And we're going to look at these things. And the objectives are for you to understand and use the Slurm scheduler to configure the cluster. And that has to be done whether you use Matlab on the terminal or in the GUI. And we also look at starting Matlab batch jobs from the command line. And there are some examples. And in this case, since we are using batch, we need to think about what projects we have to run in. And these are the projects that we have allocations for at the various centers. Sorry, I was about to sneeze. The storage space, if you're on Rackham, is this. If you're on Kebnekaise, it's here. If you're on Cosmos, your home directories are large enough that you can run from those. So I'm going to assume that you have fetched the exercises tarball to wherever you want to run. So the reason for using batch systems is that then you can get to use the compute nodes on the supercomputers. And any large resource-intensive or parallel jobs must be run through a batch script. And the reason for that is that otherwise, if everyone is running it on the login node, then the login node gets severely loaded down, and you cannot really do anything on it. And that also affects everyone else who is using it. And just one moment, I need to turn down my mail because that is popping up emails. Sorry, just one moment. Okay, it's done. Good. So the batch system used at UPPMAX, HPC2N, and LUNARC is called Slurm. And the same is the case at most of the Swedish HPC centers, and it's also used outside of Sweden a lot. Slurm is an open source job scheduler, which provides three key functions. And the first one is that it keeps track of the available system resources, like how many GPUs are there, how many CPUs, how much memory do they have, and so on. It also enforces local system resource usage and job scheduling policies, and it manages a job queue, distributing work across resources according to these policies. So it makes sure that your job gets to run when there is an open slot and no one has higher priority to get their job to run. And I have a note here. If you have attended the other days, you have learned that you ask for compute resources via the sbatch command. And in order to run a batch job, you need to create and submit a Slurm submit file. And these Slurm submit files are also called batch submit files, batch scripts, or job scripts. And you will see that if you Google and look for some examples. People call them all sorts of things, but it's all the same thing. And you can also get more guides and documentation at each of the centers about how to use the batch system in general. Matlab is integrated with Slurm. I'm going to scratch the well integrated, but it works with it. And because of that, there are several ways to run these jobs. You can use the job scheduler with the sbatch command. In the Matlab desk, inside of Matlab, there is the batch command. In the GUI, and at many centers, this is the recommended use. You can start a parpool with a predefined cluster, and that means you can get more interactivity. You can also write a batch script, just like you do for other software, and submit the job with the sbatch command from Slurm. And this is useful if you want to run long jobs and you don't need to modify the code in the meantime, because then you just submit the job and it can run for days and it will tend to itself. And that is also useful. And we also have users who do this. You can also submit jobs from inside of Matlab, and they can also be sent to the batch system and run for a long time. So, but there are reasons for doing each way. And in the following section, we will talk more about each of these. And in this one, I will mainly focus on working from the terminal, submitting it from inside submitting batch jobs from inside Matlab run from the terminal, and submitting batch job with a batch script. So those are the things I will look at. And before I go to the Matlab specifics for batch jobs, there are some useful commands that it's a good idea to know. First, how do you submit a job? Well, you do that with sbatch and then your job script. And the job script, you can name it as you want. It is customary to name it with the extension .sh or .batch, but it's not necessary. It's merely a way of making it easier for you to find it in your directory. So if we go into the Matlab directory and look, then you can see there are several files here. The .m ones are Matlab files, of course, and the .sh ones are batch submit scripts that can be submitted here, and they are on each of the systems. I'm just going to prepare these here. And if you submit one of them, for instance, I could submit this one here. And I have an error in it. Let's see what it is. It is missing of these. Let's see, the others are correct. Good. I just want to submit one of them. And I don't know why it is not working for me right now. I think I have an invisible character in it that I need to somehow find. But I just want to submit this because then I can show you some things with the batch system here. What did it complain about? Yeah, it wasn't a regular minus or whatever. So now it's submitted. Okay, so you submit a job, and as you can see here, when it's submitted, it will give you a job ID. And this job ID you can use when you check on a job, and you can also get the list of the jobs with SQ -- me. And let's try write that here. And you can see my job actually already ran, but I will submit a couple of them. And then you can see how it looks here, because then you see there is a list of job IDs. There is a list of what partitions these jobs are running in. So it's simply what type of nodes. In this case, they are running on a AMD Zen 4 CPU node. Then there is the name of the job. You can name it inside of the batch script. And that might be useful if you have a lot of jobs and you want to be able to easily find the correct one in your long list of job IDs, especially if they run for a long time and maybe you figure out you want to cancel one of them or something. Then also, if you don't name it, it will just get the name of the batch script. Then it lists the user who submitted it. And of course, that's not so useful when you are only looking at your own jobs. But if you were just doing SQ, then it would show all the jobs of everyone on the system. That's quite a lot of them, and then it might be useful to see the user. Then there's status. Status here is R for running. It can also be PD for pending or CD for completing, as well as a few other ones that are less common. Then comes the time, and it shows the time the job has run, how many nodes, or rather how many cores, and in this case 1 because it's a serial job, and then which node is it running on, and it's all running on the same one, which is BCN 1704. So, and so you get a list of jobs like this, but you can also check on a specific job with S-control show job, and I will try do that. And I will take this one here. And that gives you a larger output. This job state is failed, and I need to look at why. And the job ID is the one that we just used here, this one. It will be shown here. It also shows the priority. It shows which project it's running in. And it also shows things like when did it start, when was it submitted, when did it end, how long did it run, and things like this, as well as which partition, which node, which could be useful because maybe it's failing because there's something wrong with the node. And then we need to know that, and you can see that here. It tells you also how many nodes, how many CPUs it ran on, how many tasks, how much memory was allocated, and as well as the working directory also, the where you submitted the job from. So you get a lot of info from this one, but usually you would probably use SQ ---- me. It's the more common one, and from that you get the list of job IDs as well. So you can use that if you want to check more on them. If you want to delete a specific job, maybe you found out there's errors in it and you don't want it to sit in the queue and take up resources. You don't want it to run and take your allocation or whatever. So you just cancel it and fix whatever was and then submit it again. S-cancel and the job ID to do that. If you want to get rid of all your jobs, S-cancel -U and then your username. Useful info about a job, you can use SACCT -L-J, the job ID. There are more flags, but this will give you a reasonable output. This command gives a very wide output. It contains information about how much memory is used and things like this. So since it's very wide, you should pipe it or send it to another command, which is less. And less is able to take the flag -S to make something scrollable sideways. And that means that you will be able to scroll in the output with the arrow keys. So if you are on Kebnekaise, you can use job -usage and the job ID to get a URL you can put into a browser. And then you will be able to see information about your job in a graphical interface. Maybe you could see that it used too much memory and you need to make changes to something. So, okay. Then we have first time configurations, which is important as mentioned. First time you are running Matlab or a specific Matlab version at a center, you need to do the configuration. And there are links to doing this for each of the centers, but I will also talk about it here. And this is for all versions of Matlab 2019b and later. The ones before that, if any of those are still installed, which I'm not sure of, all later ones you need to configure to use a so-called cluster profile, which tells Matlab how to use the batch system. And you need to do it once for each cluster and for each version of Matlab that you use on this cluster. And this is done after you load the Matlab. And yeah, it tells Matlab a bit about the batch system and the parallel jobs so it can run in it. And in order to do this, you will use the command config cluster.sh and then a project ID because it actually submits a small job. And you do it that way on UPPMAX and at LUNARC. But on HPC2N, you just use config cluster.sh without anything more than that. So I will load Matlab. I will use ML Spider, as you saw in the previous section, to see which versions of Matlab are available. I'm going to load Matlab 2023A update 4 in Kebnekaise. And after doing that, I will run config cluster. And you can see it starts Matlab. Meanwhile, I will do the same in UPPMAX. And there it's called Matlab 2023B, like this. And then I will do config cluster. And the project ID there, like this. And again, I will also do this on Cosmos.
May I add that you don't have to do this for all your projects you are in, but only for your user?
Yes, only for your user. The project ID is not there to lock it to that project. It's only there because at these centers, it submits it as an actual job and it needs a project to run in.
Yes.
So that is the reason it's there. Yeah. Sorry, that is very important to mention. Config. Why is it not there? Didn't I load? I forgot the B. And then I am going to run in this project instead. The participants should run in the one that ends in 80, but I don't have access to that. It's for the students, so I'm running in this one instead. Okay, as you can see here, it now has done the config cluster on those. There is one more thing here. At Cosmos, you also need to pick which cluster, and you pick Cosmos. In a little while, it had also done that on Cosmos. Good. So now it has done the config cluster on each of the systems, and that is good. And as I mentioned on LUNARC, you can also do the config cluster within the Matlab when that is running. So for instance, on the Matlab command line or in the GUI. So you can do it either way. You can do config cluster and then it's without .sh and without the project ID. So start Matlab and run that. And again, you have to pick Cosmos. But it doesn't matter which way you do it. But you need to do one of them. And here is just an example that shows the same thing I just did here. So let's do an exercise and maybe let's just take 2 minutes and let the participants log in, load a Matlab, and then run config cluster as it's supposed to be run on the cluster you are on. So until 11:34. Okay, I'm hoping it worked. So I will continue. So the Matlab terminal interface. You have probably used the Matlab GUI on your own computer maybe, but at the HPC Center, it's possible to use it either on a terminal interface or in a GUI. And I believe that's also possible on your own laptop, of course, own desktop. So here we are going to start Matlab on the command line. We are going to do the job settings, and the job settings will have to be done whether you use the terminal or the GUI. And they are used to set various values for the job to make sure that that can run. So this is done when you want to submit things to the batch system, either from within the Matlab terminal interface or inside the Matlab GUI. And then we'll try start a job from within Matlab. And in this section, it will work only with Matlab from the shell or terminal without you having to open the GUI. And this is useful if you, for instance, only have a regular SSH connection, or if you run something that is fast and lightweight, because the GUI can be heavy to open, and especially if you need to do that remotely. So, so it's better to run just the terminal version if you have a poor network connection, or if you are sitting on a laptop and only have space for a small window while you're doing something else. So there are several reasons for running Matlab on the terminal interface instead. To start Matlab on the command line or the terminal interface, you are without running GUI. You load the Matlab version as we just did, and then you start it with this command here. Minus single comp thread should always be used whether you start the terminal interface or the GUI. It simply ensures that Matlab is running only on a single CPU and is not spawning further. And that doesn't stop it from using parallelism, because that will work anyway. This will stop the GUI to start. It will also not do the Matlab splash thingy Java, and the minus no desktop and no display. It's a good idea to run both. I found it works better, even though it sounds like it should be the same. So I'm going to start it with that on each of the system, like that. And you can see it takes a little while, and then it gets up and running. So I'm not going to do this, but of course you can work in Matlab just like you could in the GUI. It's completely the same program. There is no difference. Everything is the same. So you can define a matrix. You can do matrix addition, multiplication. You can do anything you could otherwise. So, but I am going to go to running jobs from inside of Matlab. And in order to do that, I need to set up these job settings. And I'm going to do that now. And first, we are setting the cluster. And I'm going to copy this here. And there is a difference now between Cosmos and HPC2N and UPPMAX. And that is that on UPPMAX, you just say C equals par cluster instead of giving the name of the cluster. And otherwise, it's the same. You set also additional properties: account name, that is the project ID. You set how long you want jobs to run. this 1 should not have been there. It's a mistake. It's just hours, minutes, seconds. And then you can save the profile. There are a number of other properties you can set, for instance, GPUs, and we will look at that in a little while. But for now, I want to try and set this up and get that to run. And I am reminded also that we should add this one here. That is processes per node equals 20 for UPPMAX. It is something that always need to be there, and it should have been a default, but it's not, so just set it up. Okay, let us try do this on Kebnekaise. And I suggest that people try also themselves to do this on the system they are working on. So let's do this as a type along. So this is on UPPMAX. And this here is on Cosmos. And on Cosmos, you should write Cosmos space also R2023B. Like this. And you can see now it is defined on all of the systems. So let's now set additional properties. And just like on the Matlab GUI, you can start typing a command and click tab, and it will autocomplete to a usable suggestion, usually. So here it's account name, and I am going to set it to HPC2N 2024 114, like that. And I think it wants apostrophes around it. And of course, it's exactly the same on UPPMAX. This and on Cosmos. Here, remember, I am going to use the one for the instructors, where you are instead going to use the one that ends in 80 like this. I'm going to use 68 here. So try type along and do these things. I will also set the wall time, and that of course I may change later when I want to run a different amount of time. I am just going to ask for maybe 15 minutes. I don't have a very long job to run. I'm just going to copy that and paste it on each of the systems here. And then we have one more to do, namely for UPPMAX. We are going to set the procs per node. And that should be set to 20 on UPPMAX. If you're on HPC2N or LUNARC, you don't need to set anything. And now we can save the profile. Okay. So now we have set these additional properties on each of the clusters. And you may find that you want to check what was it actually I put in. And you do that by just saying C additional properties, C.additional properties, like that. Then it will output you a list of the things you have set. And you can see it's only a small number of things that have been set here. You could also set various other constraints. And here you see the other additional properties you can set. And ones that you will be using are GPU card and GPUs per node. Let's see how they look at the other centers. And here you can see that at UPPMAX, procs per node has now been set to 20. And on Cosmos, it actually auto-set the memory usage and the procs per node. The procs per node is not set at the Kebnekaise, but it doesn't need to be set. Okay, let's just make a comment here about the job settings in the cluster profile manager. This is about the GUI, but I will mention it here because it's relevant to the job settings. You can change the job settings, of course, here on the terminal by just entering the command once more. You can unset them by entering an empty value of it. So for instance, if you wanted to remove the wall time you set, you would just do an empty command like this. But if you are doing this instead on the GUI, then there is a cluster profile manager that you can use only for the GUI. And this is only if you want to use the GUI, you don't have to use it. But after you have configured the cluster, Matlab starts with a default cluster profile. And that will include the name of the cluster as we set that. But you can view, edit, and or add to this profile by clicking the parallel here. Let's see if I can get a larger image here. The parallel here, and then there is create and manage clusters. So you go into that, and then you can get into the cluster profile manager. And this is on UPPMAX, and there is a similar one on each of the other centers. But here you see the same values also that we could see here with the c.additional properties. And if you scroll down in the window, some that appear if you select the right cluster over here, you will see a box titled Scheduler Plugins. And that lets you set SBatch parameters like you have set here. The account name, email, memory per CPU, number of processes per node, partition, etc., etc. So you can set all these same thing that you set with c.additional properties on the terminal. You can also set those in this cluster profile manager. You can also use the same commands as you do on the terminal in the GUI. So there are 3 ways for you to set it. And this looks like this when you edit these job settings within the GUI, cluster profile manager. So you can do more or less exactly the same things in the cluster manager and on the Matlab prompt, whether in the GUI or on the terminal. And the settings are saved between sessions. That is an important thing to say. And that is important to say whether you're using the GUI or the terminal. Make sure that you remember that if you, for instance, have added GPUs, then it will also have the GPU added next time you submit through Matlab. So you need to unset that you have set the GPUs in that case, and you did that with giving an empty value to it. If you are on desktop on demand on LUNARC, the settings do not override the parameters set in the GFX launcher for the Matlab GUI session itself, but rather to any batch job you submit from within the GUI. And there will be more talk about Matlab in the GUI in the next session. So let us continue. Running a job from within Matlab terminal interface. To start a simple Matlab program inside Matlab, it will use this cluster profile that you created and saved above. And you use this command here to then start a Matlab program. And my script is the name of a MATLAB script that you have, and you do not enter it with .m. Just if it was called parallel example.m, you just write parallel example here. Batch does not block MATLAB. You can working with other things meanwhile. You can, however, block it if you want it. You can say wait for the job, and then you can't really do anything except waiting for the job. Matlab saves the command window output to the diary of the job. If you're in the GUI, you can see those. You can click and see a list of them, but if you're on the terminal, you can instead use diary and then job. And after the job finishes, you can get the results by using the load function or with the job fetch output. I'm usually using job.fetch outputs, but either works. So if you need the job ID, then you can run sq --me on the command line outside of MATLAB while the job is running inside MATLAB. To get the MATLAB job ID, you do id equals job.id. And if you want to see if a job is still running inside MATLAB, you do job.state. So let's look at a serial job. After starting MATLAB, you will do this to run a serial job. To get a handle on the cluster, you use this C equals par cluster. We already did this. This example here is my function is the same as my script up there. So that is the name of the program that's running, the MATLAB program. And it could also just be a command in MATLAB. Then you can have the number of output arguments here. If there's one output, you put one here. And then any input arguments to your job, however many. Then when you have started it, you can query the state with job.state or j.state. What you should put here is the name you gave of the job. So it should actually have either been job or j here, and then the same here. So it doesn't matter. It's just whatever you called your job. If the state of the job is finished, you can fetch the result with the command here. When you don't need the result anymore, you can delete the job. If you don't, it will run for the wall time you have set. If you're running a lot of jobs, if you want to quit MATLAB and restart it later, you can retrieve the list of jobs with jobs equals c.jobs. For instance, retrieve the output of the second job in the list you get with j2 equals jobs2, and then output, you can fetch the output of a specific job. So that's also useful. Let's do a quick type along. We have now done the job settings, and let's try running the examples. And I will use the example add2.m, which adds two numbers. I am just using 1 and 2 here, but you can pick any numbers you want, of course. And this add2m script is in the exercises MATLAB directory. So let's try and do this here. We are inside MATLAB. And we are starting the job. I will do the same on each of the centers. And you can see here, it did a lot of output, and that meant it started. And we can do job state. Let's see what it says. It's running. And the time it takes to do something here is simply the time it takes before it starts running. I could also have put a semicolon after here. If I had done that, it wouldn't output this stuff here. And then you might be in doubt if it was running. But since I didn't put a semicolon after here, it waited and then output it when it started running. So in that case, I already knew it was running, but now I'm waiting for it to finish, and it's finished. I'm now going to fetch the output. And it's, surprise, surprise, 1 + 2 = 3. So I should see if it's still running. It's finished, and it's finished there. So let's see. And it ran as it should in each of them. Great. Let's continue with a parallel example. If you want to run a parallel batch job, it's very similar to running a serial job. The only thing is you now need to specify a Matlab pool to use, and that your Matlab code is parallelized, of course. And I'm going to illustrate that with an example. So to make a pool of workers and to give input, you would use a line like this. And again, job equals c.batch, the script you are running or the command you are running, the output, number of output, any input arguments, a pool, and then the number of workers. So I will do an example. Run a simple Matlab script, parallel example.m. It is located in the exercises Matlab directory. I'll create 4 workers, and I will expect 1 output. In this, I'm just using J instead of job, just to show you can name it as you want. So let's try do this. See what happens. And you see here I put a semicolon, so it should not output. It should not wait an output when it starts running. And it tells me here the submit arguments, and those actually are very useful because you can copy them and use them later when you are creating a batch script. So it tells me here that it submitted it with number of tasks equals 5. And that's true because you have 4 workers and there's also a master. So that's 5. CPUs per task is 1. And there is the project ID and the 15-minute that you asked for, or that I asked for when I created my cluster profile. That's for the job settings in it. So it's running. Let's see. I'm assuming it's running. We actually don't know that yet. Let's check with j.state. It's not only running, it's finished. I will fetch the output. And weirdly, it varies a little bit, but yeah. It's, I don't remember actually what it does. I should check. There's probably a good reason why it varies. So I would suggest you test this out. And well, it's very short. It's easy to test the same way as you did the serial one. So I will continue, and if you have questions to it later, then we can look at that after the break. But I would like to continue so I can finish this, so we can have a break, and so that we don't get behind and can start the Matlab GUI session after the break. So now we have seen we can run Matlab batch jobs from inside of Matlab. But what if we want to do a batch script and run it from the command line so that we don't need to even enter Matlab? Well, we do that by creating a batch script. And you can have serial jobs, you can have parallel jobs. Of course, you can also use GPUs. And I will also talk a little bit about GPUs at the end. So what is the difference here? When the batch script is submitted, you can't make changes to your job. It's not interactive. That is also an advantage. You can submit the job, log out, leave, do something else, and then come back later and see the results. Serial batch jobs. one thing here. It says parpool can only be used on UPPMAX and Cosmos. I'm not sure that is actually true anymore with the newest version on ASP.C2N, but I'm going to test this first. So let's look at an example of a serial batch job for UPPMAX, ASP.C2N, and LUNARC. And we're going to use the Matlab script or program Monte Carlo Pi.m. And that also is located in the exercises Matlab directory. So first, we are creating a batch script. A batch script is always started with this line, and that is because you are telling the batch system that you are running in the bash shell. A shell is a Linux thing. It has to do with how you give commands, how you set environment variables, how you script in it, a number of things like this. There are several shells. It doesn't matter, you are using the bash shell as default, and the batch system is only compatible fully with the bash shell. So just put the line there and be done with it. Then we have a line that tells us that we're going to run in this allocation, and that is on UPPMAX. The first part here, hashtag sbatch, it has to be written this way. It has to be capital letters. That is telling the batch system that this is a command to it. And -a, and also capital. And then the project ID is telling you which project project allocation to use when you're running. And this is the one on UPPMAX, the one on ASP.C2N, the one on LUNARC. Then we ask for one core. It's a serial job. And for 30 minutes or however long you want, probably 5-10 minutes is enough. It's a short job. In this case, I'm splitting the error and output. If you don't have these two lines, the output will go to a file called slurm -jobid.out. That is always the default. And you can look at that with nano, or you can look at it with well, any other thing, less, more, whatever. There are many ways to look at a file, but nano is an easy one. And that is an editor. It looks like this, nano. And then you would be able to open any file. Let's see, I just want to find one and open. So let's say I open this file, nano, and it is being edited by me, and I will let go of that. Open anyway, yes. But in any case, it looks like this. You can go through it and make edits to it. And then when you have done that, you will exit it. And you can see here, this small hat, that means hold down Control. And then to get out, click the X for exit. If you had modified it, it would ask you, should I save it? Or should I rename it, or something like this? And then you just answer yes or no to these things and maybe give the name. So Nano is a good and easy editor to use for this. Another option is to use less if you just want to look at the content. Then it will just output it to screen. And you could do that if you are just looking at these Slurm output. I don't have one here right now, but they are called Slurm minus job ID, whatever that was, and then out. So that is the default name of the output file from the batch system. But in this case, I have used a command that is telling it to put errors and also system messages into one file and the regular output to another one. Whatever you call them, it's a good idea to add the %j because that contains the job ID. And that means when you run it next time, it will not be overwritten. It will get a new name automatically. If you want to comment out something in a batch script, one of the batch commands, you do it by simply putting another hashtag in front of it. Okay. Now we are cleaning the environment, so we don't have any old modules there. And then we are adding the module that we are going to use. It can be called module load, module add, ML. These are all synonyms for loading a module. And then the name of the module. On UPPMAX, this is the name. On ASP.C2N, it looks like this. There will be several, of course, but this is the 2023 one, and this is the one for LUNARC. Otherwise, the only difference here is the project ID. Then, when you have done this, you can run your Matlab program with this command here. And time is timing the execution. You don't need that there. You could remove it. Then it would just be Matlab minus no Java minus no display, because you are not running it, you're not popping up anything, you're running a batch job. Then minus R and the name of your program or script or whatever. It needs to be in double quotes. If you have arguments to it, it needs to be given like this. You can download this script here. You can copy these here, or you can find both of them in the exercises directory. They will be named with the cluster on the .sh, the batch script. So, and you submit it with sbatch and the batch script. And as an exercise, you can try run the serial batch script. You can submit it, then check that it is running with sq ---- me, and then you can check the output, and it will be called matlab _ and the job id.out, and you can see that here, that this is what they are named. I will also talk briefly of a parallel script, and the reason for that is that I want this done before we to go to lunch, and then we can do the exercises afterwards. So a parallel batch script, it is an example one, and you can adjust it to make it work on each of the clusters. You change the project ID. And as you saw inside of Matlab here, when you submitted it, so when you try here, you get some useful arguments. And this example you could run is the parallel _ example. That's a good one to try with. And that is also what I suggest here in exercise. Because if you try running it from inside Matlab as a batch job there, then you can easily see some good arguments that you can add. So just copy those and put them in here. Each of them needs to be prefaced with hashtag sbatch. And I believe I actually also put those in the exercise directory, but I would like you to try and do that yourself. And again, note clearly that if you want to run with 4 workers, then you are using 5 cores, because you have 4 workers and 1 master. I think that is the main thing to notice. The solution is also here for each of the centers. So how do we use GPUs? Well, you can use GPUs in Matlab inside Matlab. So just like you submitted the serial and the parallel job from inside of Matlab, either the terminal or the GUI, you can do that also with GPUs. And you can also do it as a batch script. And in order to use GPUs, you have to ask for them. And if you're inside Matlab, you have to set these additional properties again. And the additional properties to set are GPU card and GPUs per node. And again, you saw them here. If you did this list here, additional properties, GPUs per node is currently set to 0 because it's you had not asked for GPUs. Let's do that now. And then say that we want 1. What did I do wrong? I didn't actually add the word GPUs per node. So like that. Let's see what happened now. Now it's set to 1. And I believe you don't have to set the GPU card on Rackham because there's only one type, namely the one that's on Snowy. Whereas on LUNARC, you actually do. You also only do that because there's only one type. That is true. So if you're at LUNARC, you set the GPUs per node equal, for instance, 1. And when that is set, you can see that it's set to 1 here. On Kebnekaise, I will start it again. There you need to set both the type of card and also how many. And on Kebnekaise, there are many types of GPUs. It's a very heterogeneous system. There are V100s, A40s, A6000s, L40S, A100, H100, and MI100. And how many depends on which type it is. But let's try to what is my profile? I haven't set the par cluster. Don't spell. Okay, I will look at this later. I don't have time to do that right now. But in any case, on HPC2N, you set GPU card for card type, and you set the GPUs per node, just like on the other centers, to how many, and then you save it again. And I would suggest that you try and simply do this. And if you're on Cosmos, just set GPUs per node, and then see that it was added with the c.additional properties. And then you can do c.additional properties GPUs per node and then unset it by giving a empty number here. And then you run c.additional properties again, and then you can see that it's gone. So if you want to run GPUs in a batch job with Matlab, then you would do something like this. And the main thing you change is that on UPPMAX, you tell it to use Snowy, which has the GPUs, and you tell it how many GPUs, and that's 1 in there. You load Matlab, and then you run your GPU-enabled Matlab script. On HPC2N, it is the same, aside from you don't just ask for how many GPUs, you also tell it what type. And it's these types. On LUNARC, to ask for GPUs, you ask for the partition GPU A100, and then how many GPUs, and that can be 1 or 2, I believe. So the key points here are at the Slurm scheduler handles the allocations to the calculation or compute nodes. Batch jobs run without interaction with the user. Batch scripts contain one part Slurm parameters describes allocation and a second part describing the actual work within the job, one or several MATLAB scripts or whatever, and also loading things. You can run MATLAB as batch jobs through a batch script or from inside MATLAB, either on the shell of the terminal or in the GUI. And you need to remember to include the possible input arguments to the MATLAB script in the batch script. And very important, you need to configure MATLAB before submitting batch jobs. Okay,